All right, guys, let us quickly check how questions might be given on our differentiation. So this is a basic part that I want you to just understand from the basic view of your derivatives. All right, the general rule when you are given the differentiation is we know that it is to calculate or to find the gradient expression of a different function that you be given. So it follows that maybe I'm given f of x, which is equivalent to ax to the exponent of n. This is where we are having the basic derivative of a function of this nature. It follows that whenever you're given this, the first derivative with respect to x is going to be given by the formula, just going to multiply this n to a. So it's going to be a n x to the exponent. You subtract 1 on the exponent. So thus, in this case, you are going to drop the exponent, this one that you're given. You're going to drop this exponent. You subtract 1 on the exponent. So that is the idea of the general rule. So it means as long I can be able to write anything in this format, as long I have anything that is written in this format, that is what I can do. So you'll be given something like, let us just say, consider that. And also the derivative, as we know that this same presentation can be given as y is equal to ax to the exponent of n. So if I'm given like this, therefore it means I'm going to have the derivative of y with respect to x. And that will be an x to the exponent of n minus 1. So meaning to say that whenever we are given this condition, we have to drop the exponent, subtract 1. What type of questions are we having there? All right, let's consider something of this nature. Given that y is equal to 2x to the exponent of 6, what is going to be the derivative of y with respect to x? So this is y with respect to x. So that means the derivative of y with respect to x is going to be, you drop this to multiply this one. So that's 2 times 6. It's like this, 2 times 6. Then it's x to the exponent of 6 minus 1. That's n minus 1. So that's going to be 6 minus 1. So that's the idea there. So you actually do not need to indicate this or to have this. No. You do not have to have this. Just going to multiply 6 times 2, which is 12. Then x to the exponent, I subtract a 1. That is going to give us a 5. So that is the derivative of y with respect to x. So the given or the presentation of our derivative, we've got so many presentations that we have, or so many indications that indicates how to find the derivative or the presentation of a derivative, like f of x. This is the first derivative. If I'm given y, this is dy dx, the derivative of y with respect to x. So sometimes you might be given even conditions whereby you have something that is under the square root. Maybe I've got the square root of x like that. Knowing that I'm supposed to have this condition of x raised to a certain exponent, I have to remove this square root, but removing this, I'm supposed to have the equivalent of that same square root. So now we are back to your exponents. Remember from our exponents, we state that if we are given something of this nature, that is x to the exponent a over b is the same as the bth root of x, everything to the exponent of a, like this, or you can have this as the bth root of x, like this, everything to the exponent of a. What does it mean? The number or the term that you're going to have here in the denominator is the one that we are having inside of the root sign. Then the numerator being the exponent there, which is our a. All right. So I erased a lot of things there. Just need these two. All right. So that will be, if we are given, it's not a 2, it's actually an a there, something like that. So the a that we have on the numerator here is this exponent, which is the same as this one. That is the same a that we have. So for a square root, what you simply need to know is that inside it, there is a 2. And this x is being raised to the exponent of a 1. So if you consider that this is the same as y is written as x to the exponent of the a, which is over the b. So the a in this case is the 1. So that will be 1 over 2. So that's the square root. So if I'm given the cube root, what does it mean? Okay, we are going to differentiate. I just want you to understand this. If we're given the cube root of x from our normal presentation, the cube root is the same as what? From this part, this is the same as there's a 1. So thus, this is the same as y is equal to x to the exponent of 1 over 3. This part of the exponent over this part that is in the root side. So thus, the moment that I just indicate or have this presentation, I'm done. Because here I can find the derivative. Remember the derivative, what I simply need is to drop this exponent to multiply here, then subtract a 1. So it means the derivative of y with respect to x is going to be, if I drop this, that's a half times a 1. There's a 1 there. So this is going to be 1 over 2. X to the exponent of what? You subtract a 1 here. So the moment that we subtract a 1, what is going to happen? That's a half minus a 1, which is a minus half. That's it. So sometimes we are given different questions depending with which level that you're using these derivatives. If you are maybe for engineering, sometimes they might ask you to even write your answers as positive exponents. Yes, you are done with your derivatives, but they might need you to write your answers as positive exponents and also in set form. So the moment that you're given to express your answer in as positive exponents, 1, also, they can ask you to do that, to leave answers in set form. These are the two things that are possibly can be asked. The set form is which format? The format that we are simply presenting the numbers or the terms under the square root of x, the square root of y, the square root of 3. That's the set form, numbers under the square root. And positive x, I think it is clearly indicating positive. The exponent must be positive. So this is a negative exponent. So as a positive exponent, this is the same as we've got dy dx, which is, remember, from our exponents that this is the same as 1 over 2 times. The moment that we've got a negative exponent, to remove the negative is same as 1 over x to the exponent of 1 over 2. Where are we taking this from? Anything that is raised to the exponent of a negative, that is 1 over x to the exponent of n. So as long you've got a negative exponent, to remove that, it's 1 over that, which is x to the exponent of n. So meaning to say this part can be presented this way, where I simply have to multiply 1 and 1, which is going to give us 1. So this is the part of just removing or having positive exponents, then 2 times the square root of x, 2 times the x to the exponent of a half. At this stage, I'm back now to say, what does the x to the exponent of a half represent? It is something that you already had before. It was the square root of a half here, and we wrote it as x to the exponent of a half. So it is not supposed to surprise us to have this written also as what? The square root of x. It's not supposed to surprise us, because it is the same thing that we had there. It was the same thing that we had, but only that the presentation now is the one. So if you check now, we have the format that is being needed here in this case. If it is a condition that answer is needed as positive exponents, and also in set form where it is possible. So this is the same scenario or the same situation that you're going to simply apply on this part to find your derivative. So as you can see that whenever we are having these, what we need is the format first. Are we seeing about the format that we need? Which is the same thing that even if you're given it as a fractional, question, f of x is given as 1 over x squared. And there you need to find the first derivative with respect to x. What are we going to do? We need the presentation of f of x is equal to ax to the exponent of n. And this is not what we're having. It's not. It's a vice versa to that. It's totally vice versa. So what are we going to do? Remember what we had from the previous case. It was x to the exponent of minus half. Then we wrote it as 1 over x to the exponent of a half. So it means if I am having this in the denominator, I can rewrite this as a term to the exponent of a negative, the x to the exponent of a negative exponent. So it is the same presentation that I'm having here from 1 over x squared as x to the exponent of a negative 2. I haven't changed anything. Same presentation. The purpose there is having this x to the exponent of, not 1 over this, not under the square root, no. Once we have this, we can find the derivative with respect to x. We drop the exponent, which is negative 2 times 1, that's a negative 2. Then we subtract a 1 on the exponent. So that will be negative 2, negative 1, which is x to the exponent of a negative 3. So from there, we can now present the same way that we had to say if it was a negative, we can take down this. We have the same thing. So we can have this as negative 2 times 1 over x cubed. What is being affected by the negative there? It is x, not negative 2. So that's 1 over x, which is the same as there. We've got an negative 2 over 1. From the fraction concept, if you're given a whole number, every whole number is same as that whole number over 1 to be a fraction or to be expressed as a fraction. That whole number over 1. So thus we can multiply the numerator to the numerator, negative 2 times 1. That will be negative 2 over 1 times x cubed, which is x cubed. So that is the first derivative with respect to x. So that's the idea there. So we're going to talk about a lot of things that you need, but in this case, are we understanding the basic part of the general rule? So it follows that if I am given this as a linear function, we are given like the equation of a straight line, which is called a linear function. Y is equal to 5x. Y is equal to negative x. Y is equal to positive 7x. These are simply linear functions whereby the derivative is simply the number that is affecting the x. How so? Okay, considering that this is a 1 here, we know that the derivative of y with respect to x was going to be, I drop the exponent, 1 times 5, which is 5x to the exponent of what? I subtract a 1 here, so that is going to be 1 minus 1, which is what? A 0. So this is the same thing as we've got 5 times x to the exponent of a 0. What is x to the exponent of a 0? X to the exponent of a 0 is what? It's 1. So that's 5 times 1, which is 5. So as we can see that we are all simply obtaining the number, this one as it is. So it follows that therefore if y is equal to ax, therefore the derivative of y with respect to x is equal to a. You don't need to find any derivative there where you have to drop the exponent. Yes, you can do that, but just take the number that is there. So if I'm given that y is equal to negative 7x, therefore the derivative of y with respect to x is going to be what? The coefficient of x. The a that is affecting x is your answer. So therefore, our answer will be a negative 7. So these are the typical questions that you're having. When it is now a constant, what is happening now? Let us consider that. I'm having just a constant. Y is equal to 5. We do not have x, but we are supposed to find the derivative of y with respect to x. And it's a constant. What's the cost? What's the condition? How do we go about it? All right. If you are to consider this, where it was actually taken from, it is like this. Y is equal to 5 is same as 5x to the exponent of a 0, because x to the exponent of a 0 is what? It's 1. 5 times 1 is what? It's a 5. So I haven't changed anything by writing it this way. It's the same question. It's the same y that I had there. X to the exponent of a 0 does not change anything. It's just a 1. So if I was to find the first derivative of y with respect to x, I was going to multiply this 0 and 5. So that's 0 times 5, that's a 0. The moment you're multiplying 0 and 5, that's a 0. Then what do? You subtract 1 on the exponent. So that will be 0 minus 1, which is minus 1. But anything multiplied, any number, any term, any expression multiplied to a 0 gives us what? A 0. So it means, therefore, the derivative of y with respect to x was going to give us what? It was going to give us a 0. That's it. The derivative of y with respect to x is going to be a 0. So therefore, whenever you have a constant, it follows that, therefore, if you are given something of this nature, let us just conclude. Whenever you have got a constant is just like, maybe I'm given a. If y is equal to a like this, therefore it follows that the derivative of y with respect to x will give us what? A 0. We do not have x there. Whenever you do not have the variable that is affected with respect to, and you do not have that same variable there, that's a 0. It means you're dealing with a constant. So what I want you to be careful is that, because they can give us another constant, and you're considering with respect to that, it does not mean that it is now a constant. A is a constant because we are differentiating with respect to x. It is not a constant if I'm differentiating with respect to a. What am I trying to say? If y is equal to a like this, and I'm differentiating y with respect to a, it's no longer a constant, it's a variable now, because it is with respect to a. And the derivative of that is going to give us what? Is going to give us a 1. Remember, we said this will just take a 1. If it was with respect to a, but this one is not with respect to a, it is with respect to x. So that makes our a to be a constant because of what it is with respect. The derivative of y is with respect to what? That's the question. It is with respect to what? If it is with respect to x, whatever that follows there, if it is not of x, it is now a constant. So with this information, I think you can be able to answer the basic part, just the basic part. So when you're now given an expression, what you're just gonna do is to separate those expressions. Let us just maybe have it like, it can be, just say it's a rule, or you can have it as a law. I don't know, just take it as a rule. It follows that if we are finding the derivative with respect to x of a certain or of maybe 2, 3 functions, depending on, I don't know how many functions we have. We have got maybe a function of f of x plus or minus gx, another function maybe plus or minus hx, plus or minus m, and so on and so on. These are functions to be taken that do not end. So on that condition, you differentiate each and every part separately. So it's the derivative with respect to x of f of x. If there's a plus, you're going to add. If there's a minus, you're going to subtract. The derivative with respect to x of what? Of gx. What am I trying to say? Every expression can be separated according to what you are given on that particular person. Like this. When I'm given a certain expression of this nature, asked to find the derivative of y with respect to x, what am I going to do? I'm simply, this indication means differentiate each separate. It does not mean that I have to write d dx, d dx, d dx. Yes, we can do that. Yes, we can do that, but there is no need to do that, guys. Just differentiate this. You will now know the basic derivative, how it is done. We multiply this by 3, 3 times 3, that is 9. Then what do? We subtract a 1 on the exponent. So that is now 3 minus a 1, which is a 2. So we've got x squared. The same thing here, 2 times 2, which is a 4. You subtract a 1 on the exponent, so that will be x to the exponent of 1, which is x. We talked about a linear expression when the exponent, I'm saying a linear, the exponent, the highest exponent is 1. That's a linear expression. Whenever you have this, you just take the coefficient of that linear expression. And that is what? A positive 5. The number that is affecting x there is what? A positive 5. So that's just a 5. What about a 7? 7 is a constant. The derivative of a constant, we talked about that, it's what? It's a 0. So it means there's nothing there. But the idea there, we are differentiating each term separate. Each term separate. Whether you're given those terms that are under the square, that are under the square root, like what we saw, whether you're, as long it can be separated. That is what you're supposed to do. So I want you to revise as much questions as you can. And sometimes they might just give us questions just for to confuse us. You know, there are those questions that they just want you to have confusion. It's not about, like, we are separating terms like addition and subtraction. They'll give you maybe something like this. Y is equal to x over the square root of x. This one is from our simplification. If you still remember from our simplification, it's x, it's square root of x. Can we have a single term? Is it possible? Yes, it is. Because this is the same as we've got x to the exponent of a 1 over what? The square root of x, which is same as x to the exponent of a half. From there, we are now back to exponents. It's no longer on logarithms. It's no longer on derivatives there, on simplification. We have our basic rules or whatever that we have on exponents. What is that we know? If we are dividing the bases that are the same, what do? We subtract the exponents. So meaning to say this part that we are seeing here, it is the same as x to the exponent of a 1 minus a half. That's 1 minus a half, which is what? Which is a half. So this is the same as y is equal to x to the exponent of a half. Once I am at this stage, I'm done. Because this, I'm used to that. There's a formula for that. Once your derivative is in this nature, we said, what are you going to do? We drop the exponent, then subtract a 1. That's the condition there. So that's the derivative of y with respect to x is going to be a half times 1, which is a half. Then we subtract 1 on a half. Half minus 1, that's minus a half. You're done. So we are now just back to that part that we talked about to say if you want to write this as positive exponent, and I think we had something that gave us an answer like this where we ended up with 1 over 2. This will be the square root of x. Because we are going to have 1 over 2 times 1 over x to the exponent of half. Just like that. So thus we've got the derivative of y with respect to x. So some of the questions you'll be wondering, what type of a question is this? They do not want you to apply any laws of your derivative to say, or the rules to say, I'm going to take this way. No. Yes, there are those questions that you have to apply the rules, like the quotient rule. It must be an expression or different terms. There's a trigonometric, an exponential, an algebraic, not something like this here. So these are the basic questions, the basics of our derivatives that we are going to have as a continuation on our next classes that you're going to have. So these are the topics that you just expect to be equipped. As long as you're revising for your engineering, you're revising for your advanced level, let us know about more questions to come so that we can revise on those questions if you have got a question, so that we can work on those questions.